Well, welcome back to Module 5, Lesson 2, and in this lesson we're going to continue the concept of looking at the difference or establishing the differences in two means, but this time we will look at using SPSS. And I'm very excited about introducing you to SPSS because in our day and age, people don't do things so much by hand. Now they may know that 24 times 26 is 624. They may know that 45 squared is 2025. I mean, there are some things that you, if you're a mathematician, you establish and you move on with. But for most folks, what we're doing is using technology. And the technology will let us move quickly, and all we need to do is to learn how to interpret the readouts of that technology. Now, I want to remind you from the previous module again, the 6-step plan. State the null hypothesis, state the alternate hypothesis, establish the critical value, find the test research statistic, draw your conclusion, and write your findings into statements. We had this problem. We're looking at the deflection temperature of type 1 and type 2, and we think that type 1 is stronger than type 2. We took a sample of each, and these samples we need to interpret. And we notice again that in differences of two means, we're going to call it a t-test, because we have to understand that these are independent. We have to understand that they have similar standard deviations or variance, homogeneity of variance, and we also need to know that they're both normally distributed. Those are the concepts that we have behind this. Are the two populations independent? Independent means one does not influence the other. If you were looking at my wife and I have been married almost 45 years, and if you look at if I'm independent of her, then no, I'm dependent on her. Matter of fact, I would have starved long ago if it wasn't for her cooking. I find myself that hunger drives me to a lot of different things. I made the bed this morning. I loaded the dishwasher. I unloaded the dishwasher. I carried out the garbage. You know, you do those things because you're not independent of the other. Her decisions affect me, and my decisions affect her. That's dependent. Independent means that one has no bearing on the other. These pipes that we're looking at, one set of them is produced by one manufacturer, one set of them produced by another manufacturer. We're looking at the deflection temperature, so they are independent. One does not control the other. Now, are they normally distributed? And I made a mistake here. I put 0. The answer, the values must have an absolute value greater than 3, so ignore that. But we will look at skewness and kurtosis, and we will do that using SPSS. Are the variances of the population equivalent? Do we have homogeneity of variance? We're going to test that as well. Now, before we get into using the software, I want to talk to you about the critical value. Doing things by hand, we used a z-score table, we used a t-score table, and understand the t-scores for a small sample, but this is a t-test. That's a completely different thing. That is comparing two independent, normally distributed curves where we have homogeneity of variance. Is called a t-test. But when we establish the critical value using software, we don't get a ZCV and we don't get a TCV. What we get is a level of significance, and it will be a value between 0 and 1. To understand this, the significance tells us the likelihood that the curves are the same. And we want that significance to be less than our error of 0.05. So our critical value, we will use alpha instead of a z-score or a TCV. We're going to say that the error that we will accept is 5%. Our error may be 1% in a problem. That's going to be the critical value. And then the test statistic is going to be the significance that the problem gives us. It's going to be very interesting, going to be a lot of fun. Now, in order to use SPSS, you have to open the software. And in mine, I went over to the applications. Of course, I'm on an Apple. You can translate this if you use an IBM, because SPS is available for an Apple. It's available for a IBM, a PC. If you want SPSS. SPSS costs about $85, $90 for an annual license. My license as a faculty cost about $500 for an annual license. As a student, by sharing your student ID, you can get the full version that I have. It's the same thing. Now, my version is 28. I was asked recently in a meeting, well, what version of SPSS do you use? That's a kind of a dumb question. That tells me somebody doesn't really know much about SPSS. SPSS is always updating versions. You buy an annual license. Mine was bought a 2-year license, version 28. Who knows what they're at now? It's a cool thing. Keep going. They'll keep changing. But those versions really are like upgrade a textbook. There's not that much difference. I think it's almost a ploy to sell you something new, but who knows? Opening the software. You go in, you find the software in your applications or in your files, and you click on SPSS statistics under your IBM. IBM owns SPSS. When you do that, it will come up with something looking like this. It's loading, and then once it loads, you come up with this screen right here. This is irrelevant. You wanna close this, and you wanna close the screen behind, because what you want to do is you want to come to this screen right here. Close the other two, they don't matter. You're going to be entering new data, and when you come into this thing, you have two different screens. Down at the bottom, it has a data view and it has a variable view. If you're going to enter your data, you're going to have to go in and name your variables first. So you go to variable view, and when you start putting in a name, it will fill in across each side. So I wanna do a group, and I want to do pipe. Now I want to encourage you with this that to do the actual test, you would think that you would put in pipe 1 and pipe 2, and you could do the test. That's not how it works with looking at the differences of two means on an independent samples. You have to put in group, and you have to put in then the pipe values. So group 1 will have values. I'll show you that in a minute. I want you to notice that by default it goes to 2 decimals. Your values, if you recall, didn't have 2 decimals. So what you have to do is you have to click on that, just touch that area right there, and you will have little arrows where you can take it down to 0. And there's nothing important and nothing difficult about that. Now, once you set your variables up, your groups, and the reason you're going to do the group is because you may do more than 2 groups. And next module, I'm going to show you how to compare 10 groups at the same time if you want to, or compare 3 or 4 or 5. The t-test is the comparing 2 groups. The ANOVA, analysis of variance, ANOVA, A-N-O-V-A, is comparing 3 or more. A t-test, in fact, is an ANOVA with only 2 groups in it. So you're going to have to set it up this way. This is important that you catch that. You're going to enter a group number, group 1, group 2, and you're going to enter this a number, and then you're going to enter the deflection values. Now, once you get your variables defined, you go into entering the data, and look, I put in group 1 down those 15 values from the table that we have, group 2, those 15 tables, and now I've got my data entered. I would suggest that you might want to go up to File and do Save, so you save your data set before you go doing a bunch of stuff with it. But look across the top at SPSS. You have the File, you can edit, view, data, transform, and analyze. File and analyze are very important. You can draw graphs of it, you can do whole lots of things, but the first thing you're going to learn to do is you're going to analyze. And when you enter analyze, it's going to give you this table. It does all sorts of things. To get your descriptives, you have to set it up differently than the way that it's set up here. Here it's set up to actually compare the means. And I will show you how to get your descriptives using a different setup. But comparing means, you go to independent sample t-test. Now, isn't that cool? You went to analyze, you entered your data, you went to analyze, compare means, and you click on independent sample t-test. And when you click on that, you come to this. Your value of your pipe and your group will be right there, so you're going to hit pipe. It's what you're testing, those deflection values. And then you're going to send your group down here, and it's going to come up with a question mark, and you're going to have to hit define group, and it will automatically define your groups, group 1 and group 2. So now look, your pipe, your deflection values are here, your group value is here. Let's look at some of the options. And I didn't do that. That's fine. Let it run. We just hit OK. And all of a sudden, my gracious, look how quick it is. It gives you pipe 1. You have 15 in that group. Here's the mean and the standard deviation. Group 2, the mean and the standard deviation. Those are the values, the number, mean, and standard deviation. Not long back, some in the class were asking, how do we calculate? Well, listen, if you got SPSS, you walk with power through the realm. Notice that I said you must have homogeneity of variance. We have Levine's test for homogeneity of variance. And listen, the significance of that is 0.497, which means that you didn't get 0.05 or less, so the variances are not different, they're the same. And then we come across, we got a t-value, degrees of freedom, but here's what's important right here. We got, in our group statistics, we got these values right here. We have a one-sided test. We have 0.169 probability that these are the same populations. Now remember, our level was 0.05. So we didn't fall below 0.05. There's not enough evidence to suggest that these are different. Now, we also need to go in and we need to look at whether or not the data sample met our requirements. We know that's independent. We have homogeneity of variance. We know that, but we need to look at skewness and kurtosis. In order to look at skewness and kurtosis, we had to set it up differently. We set it up with pipe 1, pipe 2. You went in and you defined a pipe 1, pipe 2. Then you entered in your values. And now you're going to analyze those values to get your descriptives. And you hit your descriptives, and lo and behold, you put both of them in here, and you select your options. And you choose skewness and kurtosis. And let's see what we get when we hit continue. Well, lo and behold, with this, we got the same thing we did on the others. 15 mean, pipe 1, pipe 2, standard deviation, same values. But now in our descriptive values for skewness, we got a negative 0.381 and negative 0.725. And for kurtosis. So what this means is none of those values right here exceed an absolute value of 3 or higher, which means that our curves are indeed approximately normally distributed. So they're independent, they're approximately normally distributed, and we have homogeneity of variance. Therefore, what we test is it meets the protocols and meets the assumptions. So state the null hypothesis. I will show you how to do that in just a minute. But I want to remind you that you've got this. Using this software is so easy. You just go through and you tell it what you want. You have to set it up properly. Setting up the test is different than setting up to do the descriptives and get your skewness and kurtosis, so you can tell whether it's approximately normally distributed or not. You don't have to panic. All you have to do is be able to set it up, run it, and evaluate the significance, where the significance is the likelihood that they're the same. You state the null hypothesis, the alternate hypothesis. The critical value is alpha equals 0.05. The test statistic is going to be your significance. You draw your conclusion. In this case, we would fail to reject. And then I'll show you how to write the statement in just a minute. It's very easy. You've got this. You don't have to panic. Life is good.